Okay, in this video we're going to make us a reproduction of a mercury arc rectifier. This is a picture I found on the web of one of them, and the glass is around 4 inches in diameter, and we're just going to go ahead and we're going to make one. We're not going to use mercury. We're going to make it using argon gas for the glow instead of having mercury in it. The amount of mercury that you'd see right there would be about a pound of mercury. And if you dropped that thing and broke a pound of mercury in your house, you'd have a real mess. So we're not going to use mercury when we make it. We'll just make it with argon gas, and it'll look really nice glowing. Okay, let's see what we have to do to make this thing. This is a big piece of glass, so it's not going to be a piece of cake. Okay, the first thing we're going to do is we're going to blow a hole in here, and we're going to fasten our sidearm onto it. I don't know how we're going to get away with that on this big piece, but we'll see. Alright, let's see what happens. A little bit big torch. I'm going to put a smaller head on this. That's pretty good. We're going to cut it off, diamond saw. Okay, now that gets us our opening. Let's see, use this piece here. Okay, we're a little bit small on this, so I'm going to open it up. Alright, we're just going to open this hole up a little bit. Got a right-hand carbon tool. Of course, we got a little bit big now, but we'll close it down, and that'll also center it a little better. Alright, that looks good. And that will join right onto there. Next we're going to go ahead and make the flares. We need the end caps with the electrodes. So we're going to go ahead and take this tubing and we're just going to flare it out to the diameter of the arms. All right. Pick it up with the pliers. Okay, that's our electrode. Okay, and I'll go ahead and make another one. Okay, next we're going to make our feed-throughs, tungsten feed-throughs. We're using a piece of nickel wire as the internal piece, and we use a piece of tungsten wire, this real fine tungsten wire, for the actual seal. We need one for each arm here, so a total of 3 of them. Now for the outside wire, the lead wire on the outside of the tube, we use copper wire. So we'll solder the, or weld the weld the electrode onto the copper. And we go ahead and use the pliers to just make it nice and smooth. That was not a good weld. Okay, that one's junk. We start over. Sometimes they don't do good. Okay, let's try this one. That one's solid. Okay, that one's solid. Okay, that's 1. Let's see if we get 2 out of 3. Yeah, I was off to a side on that. Let me hit it again. I might be able to center it. Okay, 1 out of 3. Alright, now we're going to make the flare for the bottom flange, or the bottom arm. Could be a little bigger. That's going to do it. Alright, now we're going to go ahead and make the pinch for the bottom. We're going to seal the electrode. We've got the electrode mounted in the right-hand chuck and the flare mounted in the other. We're going to go ahead and do the seal. Okay, first we drive the oxygen out of the tungsten. Now, heating it white hot, it drives the oxygen out so we don't get any bubbles. Okay, that should do it. Okay, now we're going to do the seal on the for the two larger flares. We got two more seals to go. Alright, now what we're going to do is we're going to take the electrode and we're going to seal it onto the bottom tube. This is making the bottom arm. That wasn't very good. Okay. Alright, that's going to do it. Okay. That looks good. Now, next we have this little rim. This is where we are right now in the end. Okay, then up from it about an inch and a half, they have a little bulb blown in there. So we're going to blow that bulb right now. Alright, right about here. Uh-oh. I got carried away. Oh. Oh, God. Well, oh, we're okay yet. I'm going to seal it back in. You got to be real careful when you're blowing air inside there. You overdo it. Okay. pretty good. A little uneven. I'm going to take this one and fatten it up. Oh yeah. That's good enough. Okay, that takes care of that. Now, the next thing we have to do is we have to cut it off. Okay, the first thing we're going to do, what we want to do is take our bottom leg and we're going to solder it right onto here, melt it right onto here. So first we have to heat the bulb up so we get it to where it won't break from expansion, and then we're going to blow a hole in it right here, and then we're going to seal this onto it. Okay? First we're going to use the annealing torch to go ahead and warm the bulb. Flame doesn't show up very good in the light, but a very light blue flame. You can see it there. It's a very light blue flame. That warms the glass very evenly. If it just spreads out over the glass and warms it evenly so we don't crack it. Okay, first thing we're going to do is blow a hole. Alright, now we have a little gap right here. I'm going to fill it in with a piece of glass. Okay, there we go. Okay, the next thing we're going to do, we have to have an evacuation stem. We have to have a way to get the gas into it. So what we're going to do is on the back side of this one, we're just going to go ahead and punch a hole, and we're going to put an evacuation stem on it. Okay. Well, unfortunately you didn't see me put the stem on there because I forgot to press the button on the damn camera. But the stem is on there, all sealed on there very nicely. Now we'll just anneal it. Alright, here we are so far. Okay, we got our two side arms, our bottom one, and our filling stem right here. And everything's so far good. Oops, drop it. Oh, wouldn't that be good? Okay, the next thing we're going to do, we have to take these arms and we have to bend them up. See, we look at the picture and the arms themselves are bent up. So what we're going to do is we're going to take these and we're going to heat them up, and we're going to make the bends and bend them up each side. Okay, to do that we're going to use the vertical lathe. Alright, here we have the vertical lathe. It turns vertically, and that allows us to have a little bit more access to the ends, because what we're going to have to do is work on the top up here. First thing we're going to do is go ahead and put our electrode in the top. And then we're going to go ahead and do the bend. Alright, first we have to heat everything up so we don't crack it. This is just plain round tubing, so it's very unlikely that it'll have any tendency to crack. Now the whole rest of the thing is sealed. We've got the air pressure pipe on the bottom of it, so we can put pressure inside of it to work the glass. Get the torch going here, ready to go. Just want to get everything heated up so we don't have any cracks. Everything's going pretty good so far. I'd like it to turn out to be a working tube, not just a one for looking at. I'm going to, right here, I'm going to seal the glass on. Okay. A little bit of a gap on the other side. I'm going to see if I can pull it over. Okay, that's about as good as it's going to go. Alright, now I'm just going to go ahead and warm that thing up all the way around. Okay. using a piece of straw here to seal it on. Fit isn't exact. Okay, the entire top is sealed on there. Now, I'm going to go around there with the air and I'm just going to puff it out so we don't have any stress. Going ahead and I have the flame set very cool, and I'm just holding it back, just letting it come down cool so we get the minimum stress in it. We don't have to anneal Pyrex too much, but just a little bit will help. Alright, that should be enough. Okay, now we'll let that cool, and then we'll put the electrode in the other side. We want to get the two electrodes in before we do the bend, because it's difficult to get the piece in the lathe once we've got the bend in it on one side. All right, here's the second one. Oh yeah. Okay, this one here fits a little better than the other one. Alright, see if I can stick it on there. Now I'm going to cool the torch off. Just going to take it down slowly, anneal it a little bit. Alright, that gets the other end in. Alright, the next thing we have to do, we've got to do this bend in the tubing. That's one of the most difficult things to do in glasswork, is to make bends in large diameter tubing, sharp bends. Now, to heat it, we use a crossfire torch. The main thing I want to heat is this bulb here, in case we hit it with the torch. Want to crack the main bulb. Okay, that should be good enough. Now let me see if I can get the crossfire lit again. Made a little banging noise there when it Okay. Okay. That looks pretty good. Okay, now what I'm going to do is I'm going to get the other torch and I'm going to heat it and even out the glass. Get the diameter to where it's evened out. I'm just going to heat portions of it and then put pressure on it with the blow hose and puff it out. Okay. All right. Hey, I'd say it looks pretty damn good. All right, I'm just going to kneel it down a little bit. Okay, we can see from the picture we have a little bulb on the end. It looks like they blew it out maybe, not very much, maybe a third of a diameter. So we're just going to puff that out a little bit on the end. The trick is to heat this thing up evenly without being able to rotate it in a lathe. We don't have to make much of a puff on it, so it's not going to be an awful lot of much better. Okay, that gives us our little bulb on the end. Now if we can do the same thing on the other side somehow. I forgot to press the camera again, damn it. It. Okay. Okay, we've got it on the vacuum system. We're going to go ahead and we're going to let it sit overnight to outgas, and then tomorrow we'll put argon in it and see if we can make it glow. Okay, we're sitting now at it's around 20 microns. All right, here we have the circuit that we're going to use to drive it. We have a 24 volt 1 amp transformer. We have a power FET. Right now we're driving it with a pulse generator. We're going to use a 555 in the actual circuit. And we have a little high voltage transformer that puts out about 5,000 volts. And we have a couple of resistors that go ahead and divides the power between the two electrodes. You can see we got a nice blue glow. If I turn the lights off, look how nice that is. Okay, and that's what it's going to look like. Okay, now we'll go ahead and make up a base for it and package it all, and that should do it. We're pulling about, it's about 40 watts that we're pulling, so it's not a lot of power. Okay. All right, now let's see. We've got our circuit board here, and we're drilling that sucker out. I got it almost drilled out here. It always helps to have a circuit board when you're doing this stuff. You know, I used to make it with vector board and stuff, but boy, you talk about a real hassle compared to a circuit board. These are homemade. This is a homemade circuit board. I just use commercial board material, and I just make them at home. Okay, what we're doing is we're setting the duty cycle of the oscillator. I've got power hooked onto it from a power supply, and I got a potentiometer here on the timing, got the scope hooked onto the output. We're going to set it to where it's going to be around 50 kilohertz, and to do that we just take it, we need about 1.5 divisions on the scope there. Okay, that'll be it right there. Okay. So now, I'm going to turn the power off, and I'm going to measure, see what resistor we need. Okay, it's about 7.5K. 6.8K, 7.5K, somewhere in that area is going to be okay. All right, so we'll find that. See, it's still got enough looseness in it to where it's not putting the glass under stress. Okay, now that wire goes to there, and these two wires go up to here. So what I'm going to do is I'm going to make some little clips. Okay, that's got it. Okay, and we turn that around like that. Oh, that looks real good. All right, we've got our power supply all mounted in there nicely. We had to make this out of aluminum exposed because it dissipates quite a bit of heat. About half the power goes into the heat sink and the other half goes into the tube. Even though we're using hex FETs and stuff, it's still pretty inefficient. All right, let's see what it looks like. All right, put it like that. Isn't that neat? That is neat. That is really nice. And there's our mercury vapor rectifier. Okay, that's it. Looks good. See, and then down here we've got our nameplate. All right. We're pulling about 45 watts out of the power line, so that's not bad. Okay, that's it.